Hi everyone. So the workshop's going to be starting in a few minutes. So until then, I'm going to get the presentation up and I'll give a little extra time just for more people to start joining the meeting as well.
I like your poster in the background and Sonic.
Oh, thank you. Thank you. Okay, awesome. It's 12 o'clock. I just want to double check that everyone can hear me.
Yep, I can hear you.
Okay, awesome. Thank you. So I guess let's get started with, the workshop. This is an introduction to C++ workshop. And just to get started with some introductions, my name is Elizabeth. I'm a senior in IBM, which is like digital media. And we're all volunteers as a part of RDT, the NYU Robotics design team. If any of the other mentors want to go ahead and just, give a brief introduction of yourselves, that'd be great.
Yeah, I'd love to. So my name is Kimberly. I am a junior at NYU, part of the robotic design team, as you could probably tell. I'm the software technical lead, and I'm a major in computer science.
Hi, I'm Michael. I also go to NYU on the robotic design team. I'm a junior studying computer engineering. I'm one of the electrical technical leads.
I go next. My name is Florian. I'm a computer engineer. I'm also a junior. I'm part of the software team working as a software engineer under Kimberly. And yeah.
Oh, awesome. Is that everybody?
My name is Rajat Kirloskar, and I'm a graduate student pursuing my master's in mechatronics and robotics, and I'm part of the electrical team at the robotic design team.
Hello everyone, I am Anik Barwa. I'm a senior studying electrical engineering at NYU, and I am part of the integration team with electrical.
Hello
Okay.
everyone, my name is Seeger, and I'm a senior studying at NYU Tandon as well, and part of the RDT teams under Michael's electric team.
I'm Peter, kind of the same thing here. I'm a junior in NYU in RDT, majoring in electrical and probably minoring in robotics.
Okay, awesome. I think that's everyone. Thank you for introducing yourselves. Just to give more background on our team as a whole, we compete in the NASA Lunobotics competition, where basically we have to like build a rover that could explore through different terrain. And here's just a quick video of a robot we had a couple seasons ago that came out really cool looking. It's actually two robots in one for deploying like the exact location you want to go to, and the other for actually digging and sifting through material. So here you see we have like a digging wheel that like actually sinks down into the ground, and it's actually able to like sift through like different minerals to like kind of simulate how it would be able to like be in space. So yeah, as I said, here you can see how it sifts through different material. So yeah, that was our robot from a few seasons ago. Really, really cool. Here's actually some of the progress our team has made over the past few years. When we first started off, we placed 26. And as you can see over time, we've only been ranking higher and higher. And our robot designs have gotten a lot more complex. And this is all the mechanical side, but none of it would be possible without programming, without the CS team that's able to, you know, actually program all these different parts to work together. And so that kind of leads us into what we're going to go over today. So we're going to be talking about what is C++ and its history, what makes it different from other programming languages, why you should learn it, and different topics within C++ syntax.
Okay, so let's start off with what is C++. So C++ is a programming language that was developed by Bjorn Stravstrup while he was working at Bell Labs in 1979. C++ is, although it's an old language, it's still being worked on and updated. So right now we have C++ 20, and the newest release is going to be later this year, C++ 23. C++ is an object-oriented programming language, and it's considered like middle or intermediate level, which basically means that it has attributes from like a high-level programming language that make it more user-friendly for people that are trying to program and develop, but it also gives you certain low-level access to like machine commands and stuff like that from low-level languages. Okay, so why would you want to learn C++? C++ ranks 6th in most popular programming languages. It's widely used in game development and complex business apps. It's used by well-known tech companies like Microsoft, NASA, and Facebook. One of the drawbacks for C++ is that it has a complex syntax. If you've ever written programs in like Python, for example, it's much easier to write, which cuts down on development time, but C++ can run a lot faster. So that's why you might want to use C++ instead. Next slide. Okay, so like I said, C++ is an object-oriented program. And basically what that means is that you can use encapsulation, which is the process of combining data members and functions into a single unit called a class. This basically allows us to, first of all, it makes our programming more readable because all of the things that are related to each other can be grouped together. So if I have one class, it can tell me I can do certain things and I have certain data all related to each other. And it also has the ability to use data hiding, which basically means that if there's certain information about our class that we only want accessible to certain other parts of our code, we can hide it and only allow what we want, the data that we want access to be accessed. Next slide. And then along with our classes, we can use inheritance, which is a process that allows one object to acquire, or it allows multiple objects to acquire the properties of a parent object. So for the example that we have here, if you have a bus, a car, and a truck, they all have certain things in common, such as they can hold fuel at a certain amount, they can hold a certain amount of people, and they all need some way to stop so that they don't run into everything. And so you can make a parent class called vehicles that has all of these attributes already associated with it. And now we can simply create our child classes, the bus, car, and truck, that can access these attributes easily, and we don't need to be rewriting all of this code for each one. Next slide. And along with using parent classes and child classes in inheritance, we can have polymorphism. And that allows us to have different functions for the same, different operations for the same function. So basically, if I have a shape, so like I'm using a graphical user interface and I want to be able to draw this shape, I can have a parent class that has this draw function. But I want all of my shapes to be able to draw. But if I want to draw a triangle, obviously I don't want to do the same thing as if I draw a rectangle, because they don't look the same. So if I want them all to have this same overarching functionality, but do different specific things within that, we can use polymorphism to do that. Next slide. Okay, so static versus dynamic typing. So data types are obviously important in all programming languages, and each language handles this differently. If you've ever used a language like Python or Ruby or PHP, you use dynamic typing, which basically means that your data type for a variable doesn't need to remain the same throughout the program. The type is only known at runtime. This makes things easy if you wanted to start your program with one variable and at the beginning it's an integer and then at the end it's a string. That can be useful. But with static typing, you need to know the type at compile time. So languages like C, Java, and obviously C++ that we're talking about, you need to explicitly state the data type that you are using. So that's typically when you're creating the variable. So if you have an integer I is going to be an integer throughout the entire program. And that basically is used in order to make your program run more smoothly. It can also be very useful to keep your data types the same just for readability. And yeah, next slide. Okay, so before I pass it off to Rajat, I'm going to talk about some C++ fundamentals. So every program has to have a function called main. Some other programs you don't need to have a main, but for C++, if you want something to run, it needs to be called within your main function, or some branching from something called within main. For your blocks of code, you need to use braces. So like if you're writing an if statement or a for statement, everything that is within that block needs to be surrounded by braces. Statements have to end with a semicolon. If you've never written code in a language where you need to end with a semicolon, this can be very annoying at the beginning, because if you forget to write one in, your program just probably won't run. And so you have to make sure that you have it on every single statement. Every function has to state what type it returns. So like I said before, C is a static type, statically typed variables. So your functions also need to say what they return, because like, for example, if you're creating a variable and you're just making the variable the output of this function, C++ needs to know that those types are going to line up. So your functions also have to specify what type they're going to return. Your main function has to return an integer. That value is going to be 0 if your program has successfully completed. And if your program is going to return anything, then it has to have a return statement. Do you need to allocate memory? So you can allocate memory on the heap. You don't need to. It depends what you're trying to do in your program. But you can allocate memory on the heap, and then you need to specifically delete it. I hope that answers your question. And then if the function returns anything, then it needs to have a return statement. So you can have a function that doesn't return anything, in which case you have to specify void, which means that it's not returning anything. But if you do have, say you're returning an integer, you have to have a return statement, because otherwise C++ would think you're not returning an integer. And that's it for this.
Hello everyone. So my name is Rajat and I'm going to be presenting the next few slides. So what you see here on the screen is a typical way a C++ code is written. The first line always starts with a header file, which is typically the IOStream library. You usually include your header files at the beginning of your code using the hash include preprocessor directive. So header files usually contain definitions of functions and data types and are imported using the preprocessor directive hash include. What this does is it basically asks the compiler to process these files before the compilation of your code. For example, if you wanted to perform, let's say, the operation a raised to b, you would have to include the CMath header file using the hash include preprocessor directive. The second line here, as we can see, says is basically using the namespace std. These are basically used to organize your code into logical groups and to prevent name collisions. I can best explain this with an example. Let's say we have two different functions with the same name in two different libraries. Your compiler does not know which one to execute. So when it sees the line using namespace std, it knows that it needs to execute the function defined in the standard library. Next, we define the function, and as Michael mentioned previously, it always defines an integer data type. Hence, we write the int main. This is simple code. Hence, we've written cout inside, which is basically printing the statement hello world, and you're returning 0 as an integer to indicate a successful execution of the code. Next slide, please. here are examples of a few libraries that you can use in C++. You have hash include string, hash include vector, and hash include fstream. So what you can do using, so basically, you need to include the vector header file if you want to play around with vectors in your code. Vectors in C++ are basically a sequence of containers representing arrays that can change their size during runtime. So unlike arrays, you do not need to predefine the size for a vector. And the fstream header file is basically used when you want to read or write into another file. Next slide. So here are a few variables and types that you can use in C++, which is pretty much the same like in other programming languages. So we have the integer data type, which is used to store numerical values. We have the float data type, which is used to store decimal values, and the Boolean data type, which is used to store true or false, where true represents 1 and false represents 0. Another data type here is the char data type, where you would store individual characters, and these characters need to be mentioned in single quotation marks, unlike strings, where you would need the double quotation marks. Strings are nothing but a combination of characters, which are typically words. Next slide.
So do you guys want me to go to the next slide, or do you want me to click on variable syntax?
Sorry?
Oh, do you want me to click on variable syntax, or do you want me to go to the next slide?
Okay, sure, you can click on variable syntax.
Okay, I think you guys should still be able to see this. Are you able to see the, okay, awesome.
Yes. Okay, so here is an example where you can see the things that we've discussed so far. We have the header file, we're using the namespace std library. In the main function, we've defined a char having the variable name a123, and you're assigning the character a. As you can see, it's written in single quotation marks, and basically you're just printing the character with the data that is stored into the a123 type, that is the char type. To demonstrate the float data type, we have another variable called b, which is storing the value of pi, which is 3.14. As you can see, since it includes a decimal point, it's stored in the float data type. And finally, we have another Boolean variable which stores false. And as I mentioned earlier, true or false is stored in, yeah, so Boolean is basically returning a true or false data type. In this case, it's false. So next we move on to the user input. The cout object in C++ is an object of class OStream, and it is defined in the IOStream header file, which we write at the beginning of the code. So we would typically use cout when you would want to print something on your screen. As you can see in the example here, we have cout, which prints hello world, which is a typical phrase we would print in any coding language at the beginner. Endl is basically telling your endl basically changes your line. You want to go to the next line. Another way to represent endl could be \n, and I think it's pretty much your preference whether you would like to write that or simply endl. The cn object in C++ is an object of class IOStream and is used to take input from the user. Be it so you can have various data types like string, integers, floats, and whenever you want to have an input from the user, you would use cn. In this case, it's a string, so you would use cn with the greater than sign twice. followed by the variable to accept the input from the user. So here is an example code, pretty much the same thing. You have a header file. You're telling the compiler to use the standard namespace library. Your main function returns an integer value, hence we write int main. We're defining a data type of string data type with a variable name as s. We're taking an input from the user using the cin function and simply printing whatever the user has inputted using cout. And since the code runs successfully, you would have to return 0. So here is a very simple exercise for you guys. You just have to fill in the blanks. And if anyone wants to solve this, you can just write in the comment section. So you basically have two variables, x and y, storing integer values, hence they've been defined with the int data type. You're asking the user to type in a value. The way we would take in the value is by writing cin in the first blank and x in the second blank. Similarly, for the second number, we would again take cn and y for the second integer value from the user. And lastly, we are finding the sum by adding the two numbers that the user has inputted and displaying it using cout. Next slide. Yeah, that's the answer to the exercise. And I'd like to hand over to Kimberly, who will continue from here on.
Hi, everyone. So now we're going to get into our first data structure in C++. So the first one that we're going to go over is a data structure called arrays. So arrays are a collection of the same data type stored at contiguous memory locations. And what this basically means is that in your computer, the way that the elements in this array is stored is one after the other. So because of this attribute of arrays, that means that when you create an array in C++, you have to know the size of the array when you declare it. And so what this also means is that the size of the array cannot change after you declare it. But one benefit of arrays having this characteristic is that you can access any element inside of the array randomly. So if you can see here at the second bullet, that's the syntax for creating an array. So in this case, we're creating an array of strings, which we're going to call car. And this array will have a size of 4. Next slide, please. So for example, another way of declaring an array is if you already knew all the values that you needed for this array, you can declare them right away using the curly braces and then listing out all of the elements of the array. You just have to make sure that the size of the array that you declare on the left-hand side matches the number of elements that you declare on the right-hand side. And here you can see another example, but this time with integers. So Elizabeth, if you could click on array syntax for me. So this is just an example of how you can declare arrays. So if you look at the top from lines 8 to 10, those are 3 different ways that you can declare arrays. So we reviewed what is on line 8 and on line 10. And on line 9, what it basically does is if you do not give a specific size for the array, it will automatically get this number by how many elements you declare on the right-hand side. For lines 13 to 14 in newer C++ versions, you can pass in a variable for the size of the array. If we wanted to change an element value on line 20, we can see how to do that, where if we want to change the very first element, we would do array2 at the index, and the first element has an index of 0. And we can change this and set this equal to whatever value we want, as long as it's the same data type as the array expects. So if you look at lines 22 to 25, it kind of elaborates on why the indexing of elements in an array is going to start at 0. And this is pretty common throughout any other programming languages that you might have experience with. Okay, nice. All right, so moving on to an array exercise. So this is basically 5 examples, and we're just going to go through them to see if they are of correct syntax or not. So I'll give you guys a few minutes to look over it before we start going over the answers. All right, so I'm gonna start going over them. So for the very first one, do we think that one's going to be a syntax error, or is this correct syntax? So for the very first one, this will actually be a syntax error, and it's a very, very small detail, but in C++, strings have to be lowercase when you want to use a string. So the fact that this is an uppercase S would mean that it wouldn't compile in C++. It's a very minute detail, but something that C++ does yell at you for if you do. Now moving on to the next one, is this correct syntax or a syntax error? Yes, so this would be a syntax error. So remember that arrays can only take in one data type at a time. And so if we declare an array of integers of size 2, but we set the elements to be strings, then this will lead to a syntax error. Now moving on to the next one, is this going to be correct syntax or a syntax error? Yep, this is correct syntax. So you can tell because on the left-hand side, we declare this as an array of integers, and on the right-hand side, we do declare integers. And we also see that the size of the array that we say on the left-hand side of 3 also matches the number of elements on the right-hand side. Now to the next one, correct syntax or syntax error. Exactly, it is correct because again, we declare on the left-hand side that we want an array of strings of size 2, and on the right-hand side, we have 2 elements that are of type string. Now for the very last one. Yes, that will be an error. And the reason why is because in C++, if you put quotations around anything, that is syntax for declaring a string. So although each element in the array is technically a number that we recognize as a number, in C++, because of the quotations around every single number, it registers these as strings. So that wouldn't match the array of integers that we declare on the left-hand side. Any questions on any of these? Okay, nice. Next slide. Okay, so we just covered a data structure of arrays, which basically imply that you need to know the size of the array at declaration time. And so here we introduce another data structure called vectors, where you don't have to know the size of it at declaration time. So this would mean that vectors can change in size as your file progresses. So we can see here at the bottom, the syntax for declaring a vector is we have vector on the left-hand side and open caret. Then we state the data type that the vector should expect, because just like arrays, vectors can only have one type. And then on the right-hand side, we declare the name of the vector. That should say vector instead. And if you ever want to work with vectors inside of your file, at the very top of your file, you need to have a hashtag include and then the open caret vector close caret. And that's how C++ will know how to recognize your vector syntax. Next slide. So these are just some common methods that are utilized with vectors. So here we have for the very first one, a sign that expects two parameters. The first one being the size of the vector, and the second one being the value that you want each element in this vector to have. So if you look at 1a, if we were to utilize this method, v1.assign to 100 would make a vector of size 2, where each element is 100. Then we have pushback. This expects one parameter. And essentially, this would add in an element to the very end of the vector. If you wanted to remove the very last element of a vector, this would call for the method pop back. If you wanted to insert a particular element at a certain index, then you would use insert. And then if you use clear, this would remove all of the elements in the vector and start you from scratch. Next slide, please. Lastly, there's also swap, and this actually expects one parameter, which would be the second vector that you want to swap the elements with. So this would essentially just take two vectors and it would swap the elements of vector 1 with the elements of vector 2 and vice versa. So if you could click on vector syntax, please. So this is just an example on how these methods could be utilized. So starting with line 7, we are declaring a vector int that we are naming v1. On line 10, we're assigning 5 elements to v1 that are of value 2. And then on line 13, we push back an element of 15, which basically means that v1 will now have all of the previous elements that we declared on line 10 with the addition of 15 at the very end of the vector. If we wanted to remove this final element, we would do v1.popback, which you can see in the comment right next to it. We'd just get rid of the 15 at the very end. And then at line 21, let's say we wanted to add in an element at index 2 with a value of 3. So we can see for the very first one, we actually pass in something called v1.begin close parentheses. And essentially what this does is it passes in where the vector first begins. Because if you remember with arrays, we have this in contiguous memory, but with vectors, because the size can be dynamic, the computer has a specific location for begin, and that's why we can't just automatically pass in an index of 2. We need to first pass in where the vector begins. So if you look in the comments, you can see how v1 mutates on line 23 after we call in insert. If we wanted to clear the vector, on line 26, we just call v1.clear, and that sets the vector back to no elements. And lastly, if we wanted to swap the elements of one vector with another vector, making sure that they're of the same type. So in this case, because v1 is a vector of integers, v2 must also be a vector of integers. On line 30, we would swap the elements of v1 with v2, and you can see in the comment on lines 32 and 33 how the two vectors change in values. Any questions on anything relating to vectors? Yes, for a question? Line 21. Yeah, so what's your question about line 21? Yes, so v1.insert, the method insert for vectors, expects two parameters. The first one being the index that you want to add in your new element into. And the second parameter will actually be the value of the element. So let's look at lines 18 to 20, because in the comment, it gives a better explanation. So on line 20, we see the current state of v1. So here we have 5 elements with a maximum index of 4. So if we want to add in an element of the value 3 at index 2, what we first have to do is call v1.begin, because that's how the computer will understand you want to add in an element at index 2, starting from the beginning of the vector. And once you pass this value in, along with the element that you want to add in at that index, then you can see on line 23 how v1 changes. So for example, we wanted to add in the element 3 at index 2. So on line 23, we can see that at index 2, this now contains the new element 3, and everything after that is pretty much pushed over by 1 to make space for this new element. Does that help? Okay, awesome.
All right, thank you, Kimberly. So my name is Seeger, and I will be presenting the slides for loops. Loops are very easy. It's very simple. And we'll be covering like two main types of loops, for loops and while loops. So for loops, you can see it's usually used when you know how many times you want a block of code to run. So this, you can see the syntax below here. The main difference between the main point for loops is that you have to pass in 3 parameters. So you can see you specify 3 values: the start value, the executing condition, and step. So for starting value here, let's just say we want to print the numbers from 0 through 4. We start initializing I as an integer and set it to 0. So that will be one of the parameters. And then for executing condition, we want to stop when I reaches 5. So we specify it to stop when we specify it to run when I is smaller than 5. And then that's the second parameter. So for the last parameter, the step basically means how much you want to increment I, or how much you want to decrement, depending on what you choose to do. So here, we're just printing out I every iteration, and the output you can see on the right is 0 to 4. Some of you might have a question about like why it wouldn't print 5. And we can just look at what happens when the loop gets to 5. So when I is equal to 5, it would check the executing condition. And 5 is obviously not smaller than 5, so that condition fails, so it would not print 5. The loop would stop there. And I guess another subtle thing is like here, the syntax is using cout, like the new cout I with a /n, and if anybody doesn't know what the /n means, is basically the character for a new line. It's the same if you would write NL. So yeah, if you go on the next slide. So while loop is it execute a block of code as long as the condition is true. So if you remember, for loop, you need to specify 3 parameters. With while loop, you only need to have a condition. And there's a variation for this, which is the do while loop, but let's just focus on while loop first, and then we can go over do while next. So if you just focus on the left side here for while loop, the syntax is, you can see right there, while you give it a condition, and then within that block is the code to be executed. And this it's the same example as the for loop. We want to print out numbers 0 through 4, but the only thing is we don't have an initialization block inside the where you pass into the loop anymore. So you have to initialize it first, and then you give it a condition into the while loop when I is smaller than 5. And then within the code, it's the same thing, but here, to replace the for loop incrementation or decrementation step, we do it after we print out the number, which is you see at the line I++ there. That's the basically operator for increment. And the variation of do while is on the right, and it's basically executes the code first. So you can see the syntax is a little bit different. So you have to do before you do a while. So if you focus on the do block, we have the exact same thing as the while loop, but we have the while condition at the end. what this means is basically it does not check the condition first. It executes the code first, and then it checks the condition. Is there any questions about while loops or for loops? Okay, great. Could go on to the next slide. So here's like a little exercise for you guys. If you guys could write a program using a loop that prints out numbers from 0 through 10. You guys can write it in using for loops or while loops, or you can try both. If you want an extra challenge, you can try print out the even numbers only between 0 and 10. And I'll give you guys a little time to work on this. If you guys have any questions, you can just type it in comments, or if anybody's finished, you can also type in the comments.
Since we're a little pressed for time, I'm going to give you guys another minute or two before we like start going over the solution for it. But yeah, just a heads up for that.
I think we can start going over solutions, I guess. Is everyone finished, or do you guys want some extra time? All right, so here's the answer. Don't worry about like not getting on the first try. Just I guess you can screenshot this and then review it later. So here are two ways to write it, obviously using while loop and for loop. So using while loop, we obviously need to initialize I as an integer equal to 0 first. And then we start defining the while loop. So while we want I is smaller than or equal to 10, we want to print it out. So after we print it out, we want to increment I so that it goes up by 1, and then it would execute the code again, and then I print that out again. And then until I is 10 or 11 at this point, because when I reaches 10, it would execute the code as well. But at the end, when it increments it to 11, it checks back at the executing condition. 11 does not. 11 is not smaller than or equal to 10, so it would stop. It's a similar thing for loop here, but it's just the way you define it is different. Is there any question about this? Okay, great. We can go on the next slide. So for the challenge problem, if you only want to print out the even numbers, we could change how much we increment I by. So for while loop inside the coding block, we basically change the syntax of I++ into I plus equals to 2. That way we increment I by 2 every time. So it goes from 0 to 2 to 4 and so on. And obviously it would still be when I is equal to 10, it would still print out 10 here. I guess there's a little mistake here on the slide when it should be while at the second line, it should be while I is smaller than equal to 10 so that it would print out 10. And then for loop, it's a similar thing. You basically just change the third parameter, the step, to I plus equals to 2. So that every time it will increment I by 2. Is there any questions about this? Okay, next slide, please. Okay, so there's a little bit of an extra thing here. Let's just say we want to make the function stop when I reaches 5. So in this case, we're printing out, 0 through 10. It's the same thing we've done before. But if we wanted to stop here, let's put a condition like if I is equals to 5. If I is equal to 5, then we wanted to stop. Does anybody know what we should put in these in this white blank here to make this work? Do you mean I should put I is equals 11 at the white blank, Barth? So you basically start, so let's say if I is equal to 5, we check if I is equal to 5. Okay, when I is equal to 5, I set I to 11, right? Is that what you mean? Okay, yeah, that is a way to do it. So that is basically what Barth is saying is when I reaches 5, we want to make I 11 so that the executing condition fails. When I is equal to 11, 11 is smaller than 10, and obviously the code would stop. Yes, that's a very smart way to do it. But there's a much easier way to do it, or like simpler way to do it. Yeah, Anik is right. We just put break there, and the function would stop no matter what. And the output would stop at 5 because we specify the condition to break before we print things out. So it would only print until 4. Yes, that's correct. That's correct. Because when we have so Michael brings up a great point. If you can go back to the previous slide. So if we do it as Bart said, we make I is equal to 11, it doesn't immediately stop the loop. The loop would still run because there's a second print statement behind it. So then we would print 11. So the output would actually be 0, 1, 2, 3, 4, and then there will be 11 there. Okay, is there any questions for this? All right, great. With that, I'll hand over to Anik.
Hello everyone. So in C++, file input and output is pretty straightforward. To read a file, we need a stream object to get the input from the file. And for that, we have to use the input stream class, and it is denoted as if stream. And the data here is a variable name for the if stream object. And inside that, we have in parentheses, we have the text file where we'll be reading from. After that, we have to check if the file is opened successfully. And for that, we can use an if statement. And if it returns false, then we can just return an error and exit out of the program. After we check the file if it's opened successfully or not, we can read the file using a while loop. And we can also use a get line inside the while statement to read each of the lines all together. Then after that, we can just close the file using data.close. Next slide.
Okay, thank you. My name is Florian, and we're going to be going over the next data struct, a data structure struct. And what a struct is it's a data structure containing a bunch of members. It could be any type of variables that could be defined in your C++ program. A struct can be defined in you just need the keyword struct, any type of variable name, and then curly brace open and closed when defining it. If we look at the member types and the member names, basically that's what it was, with containing a bunch of members. A member type could be like an integer or just another struct or another type of data structure you're using. It doesn't matter. You'll just have it in, and it's going to be encapsulated in this struct that you're creating. Also, something new that I didn't know before until recently is that you could also define structs right after you define the actual struct, if that makes any sense. So where it says object names, you could define some objects of certain variable names, and you could define it right there and then. Usually when I do it in the future, or usually when I did in the past, I would just do that in main. I didn't know this until recently, so I thought it was a pretty cool thing. Can we go to the next slide? Thank you. So here is a struct example. We're going to make a struct called person. And in our person struct, we're going to have two members. One of them is going to be a string of your name, and then another is going to be an integer of your age. And so the way we did it is that we define using the struct keyword and then name the struct person, open curly brace. And then, as we said before, we use string as our data type, and then name as our variable name, and then the same thing with our int and then the age. And as I was talking about last slide, we use person1 as our variable name, and this person1 will be of type person, which is a struct and has the two data members. If we go into main, what we're doing now is we're using something called the dot operator. And what the dot operator does is it goes into the object's data members that you're trying to either change or just get the value of. So here we're trying to change it, and we're trying to initialize it actually. And here the first line, person1 dot name equals happy. So now after that line runs, we're going to have person1's name being happy. So anytime we want, we could also just look into that person1 dot name like we are doing in the cout, and it will print out happy. And then the same thing goes with age, will be a 5. So if we go to cout, it's going to say happy age is 5, and then the end of the line. You can go to the next slide, please. Thank you very much. Okay, so there's a little example that we could do. Which of the following syntaxes for defining a struct are incorrect? I'll give like 20 seconds. Don't stress too much about it. Just try to do your best, and yeah, 20 seconds. Also, one last thing I forgot to say is that after every struct initialization with the curly braces, you're also supposed to put a semicolon right after that. And yeah, just a small little thing. Don't forget to miss. Other than that, we could go into the answers of the question. So if we look at all of these, none of them are actually incorrect. All of them are correct. And just go back to the last slide really quick so I could explain. For A, it was just like our example, pretty much the same thing. That's how we were taught in the last couple slides. B is the way I would do it usually. But now I actually kind of like A a lot more, just saves a lot of time when you're doing a lot of, variable names. But yeah, A is another way that I used to do where you just would call the actual type in main. So it'd be person type and then the variable name, just like any other variable. And then C is just like A, it's just using two variables now. So there's going to be two persons that we could use, person one and person two. You can go on to the next other slide. Thank you. One other struct problem that we could go through quickly. This is a pretty big one, but we could just go through it and I explain. The prompt of the question is now create your own book class. I think I was supposed to say struct, but create your own book struct with members name, number of pages, author, and if the book is still buyable. So well, they're going to give us 3 books and we're going to just need to go through that. Just before we get into the actual like answer to the question, there's going to be a name. So it's probably going to be a string and then a number of pages. So probably an integer and an author, probably also a string because it's going to be the author's name. And if the book is still buyable, that's like a true or false, like is it buyable or is it not buyable? So we're probably going to use a type called Boolean, which is just with the keyword bool. And yeah, we're going to have to create 3 books out of those data members. So if we go to the next slide, please. Okay, so what this does is basically what I was saying before. It creates a struct with the struct keyword, names it book, and we're going to have 4 data members inside, one being a string for name, another being a string for the author, an integer for the pages, and a bool for if it's buyable. Just so you guys know, if you do try to like see out before you actually initialize any of these variables, I think it's different for your operating system. I'm not too 100% sure on that, but when I tried this myself, it just printed out nothing. So it might be different, it might give you just a random garbage value, but I think it usually is just, it prints out nothing because you haven't initialized it yet. Another thing we also do is, if you look at the syntax right under the struct data members, it says library, and then in brackets, it says 3. And back to when Kimberly was talking about arrays, it's basically just that. It's just a array of array of books with 3 of them inside. How do I make it write the value? Like initialize it, Parth? Like write library.name. Are you meaning like, oh, you want to like change the name of the library object? Because currently with the library, there's 3 of them. So if you look into main, we're doing an example on the first one, which is object library 0. Make it output the value of the struct of one of them. So the way the structs work is it prints only specifically what you want it to print. So like say like if you look at the example, you could always cut me off if I'm not getting your question quite correctly. But if you look at the example, like it says library 0, which is the array. It's also just a book, and it will take the name and then change the name. So if we want to actually print out that name that we just initialized, we just do cout library 0 dot name and then end line, and then it'll print the first book in that array. Because library, all it is just an array of books, and that's it. Does that make sense? Okay, perfect. So yeah, all it is, library is just an array of books, and you could initialize it right after actually initializing the struct. And yeah, in main, all we do is just take the first book, change the name, change the page, or initialize the name, pages, author, and if it's buyable. So I think back to our prompt, it told us to make a book name as How to Steal a Dog with 192 pages, with Barbara O'Connor, and if it's viable and it's true, that's viable. We could go on to the next slide, please. And then it's the same thing continued. We're just doing the same thing with the other 2 books. And that's about it in terms of actually initializing the book struct or the book objects that we got from the struct. And like we did with the for loops in previous slides, we just use I as our index, and we go through the array and we print each and every single one of them. So if the output, I don't know if we have the output, but the output would just print them like we are initializing them. It would print it line by line for each of the books. Next slide, please. And yeah, I'll hand it off to Peter.
Hi, thanks for that. And thanks for sticking around, guys. So this is gonna be the last thing before we end this presentation. So we're gonna end it on a pretty easy note with the classes. So what are classes? I'm pretty sure a lot of you would know. If you know any basic programming, classes allows you to create like a type of object. Essentially, it's an object type. Classes, like for example, if you have a person, like if you have a guy, right? His name is Ben, right? His age is 15. He weighs this and this, right? Ben himself is technically considered an object, right? But as a type, he would also be considered a person. So that template of a person, his name, his age, his weight, so on and so forth, is the template which is considered a class, right? So this class, right, can be given attributes like a name, right, as I said before, and this object, right, has a certain thing like an age, like so and so, and it can also be assigned behaviors with this object being able to like have a birthday or being able to change a name. Another thing, and again, like these class attributes by default are technically private, so most outside code can't really actually access classes unless you specifically declare that it should be public. Some of you may be wondering what classes are specifically used for. Mainly classes are used for like if you want to make code much smaller, instead of assigning a person in like a certain variable, right, something over and over again, right, and you have like 50 lines of code. In order to reduce that, essentially, you could just use classes and reduce something like 50 lines of code into essentially 5 lines of code. Instead of having to assign constantly over and over again, you could just put into a class, which you have a set template, right, and you could just assign certain things in that template. Next slide. Right, so this is one of the class examples. So as you can see here, this class, right, is they're calling it person in this case, right? And we're gonna call this class a person, right? And we set it to public. You can set any class to public by just simply putting public and just putting a colon at the end. And as you can see, you put in the certain assignments such as string names, the hobby, int, age, so on and so forth, right? And anytime you want to call onto this class, you just type in person, right? And you assign it essentially call that class Abigail. You call the object that's found in the class. So if you find like asking for like person Abigail, right? You can then you then have the ability to start assigning names such as Abigail.name is now Abigail, right? And her age is 17, Abigail. So now anytime you call Abigail from that class, you can automatically have this this template. This whole Abigail name will be Abigail, age is 17. That's automatically saved into your class now, as you did. So yeah, that's essentially about it.
Okay, thank you so much for that. So that was, our workshop on an introduction to C++. Thank you all for joining. I'll be sharing these slides in the Discord server. That way you guys can look back at them because I know we had to rush through some of the later topics. So feel free to check them out again later. And like I said, we're also answering questions in the server. So if you guys need any programming help, just let us know. And yeah, if you guys have any other last minute questions, feel free to drop them in the chat. But if not, you're also free to leave. Thank you to all the other mentors who helped me out today. And yeah.
Bye, everyone.
Have a good one, everyone.